All right, so here's the truth table for AND. They both have to be true. We're using zeros for false and ones for true. So the only case that an AND is true is when both sides of it are true. Or only one side has to be true. So the only time it's false is when neither side are true. Otherwise, it's always true. And not just flips it. The not of 0, the not of true is false, the not of false is true. These are the operators used in other languages, such as Java and C and C++ and so on. And can be considered Boolean multiplication, or can be considered Boolean addition. And if you take a logic course, and there are courses in logic, if you go to four-year school or whatever, you'll see expressions like this: A, B plus CD. And what that means is A and B or C and D. Just to kind of expand it out like that. And you can use parentheses to group this kind of stuff together. A, like that, would mean A and, but you still have to keep the parentheses. C, now what did we say addition was? Look 5 lines up, 6 lines up. Right there. Or it can be considered Boolean addition. So if we're doing B plus CD, that's B or C and D, like that. Now I'm just giving you a taste of this. Obviously this is not a logic class. But I want you kind of familiar, just tuck it away in your brain, that you can express logical expressions like that, as well as with the whole words and or. And they multiply out. If you do A, B plus C like that, that means A and B or C, but it also means A, B plus A, C. So A and B or A and C. Yeah, big deal. Well, going to reverse gives you, something more interesting. Like if you have X, Y plus XAB, you could, just like the distributive property in our old math classes, you could do X parentheses Y plus AB, right? Same thing, just like these were variables and you were doing, junior high math or whatever. This idea is pretty useful to you, because if you had to write this, A and B or A and C, maybe it would be clearer if you wrote it like that, A and B or C. Maybe not. You just get to pick whichever one you think is clear. So we've done that range business where we're checking to see if something is between temperatures. Like ice is ice is less than 32, boiling is greater than 212. So we could do something like this. Liquid is equal to temperature greater than or equal to 32, and temperature is less than or equal to 212. So you use and for ranges. What if you wanted to do the opposite and you wanted to see if it was not a liquid? So not liquid is equal to, you're going to have to reverse it. You're going to have to make these, less than 32 or greater than 212. And you can't check and there, right? Because nothing could be less than 32. Nothing could, if it was also greater than 212. So you're going to have to chain an or there instead. Temperature greater than 32 and temperature less. No, I've already goofed that. Temperature less than 32 and temperature greater than 212. So you use that to exclude from a range. But we see this word not here. That just means that we could put a not around this expression and it would be just as valid, right? Because here we're checking to see if something is in the range. Well, if it's not in the range, then it would be a not liquid. So an alternative to using or and excluding the range would be just to write it like this, to take that line of code and use not around it, right? Just like that. We check to see if it was within the range, and then we reverse the truthiness of it. So yeah, is it greater than 32 and less than 212? So at 70 degrees, it is greater than 32. It is less than 212, so it's a liquid. So we flip it with not. Now it's a false, and that was supposed to be not liquid there. Like that. Hope that makes sense. There is an assignment coming up on using and, or, and not. I kind of copied it out of the book, but I changed it quite a bit to hone in on the things that I want. It's one of the assignments in the back of Chapter 4, which means that it's adequately explained all the way through Chapter 4. So if my explanation here hasn't been enough, check the PowerPoint and read the book, and then you'll do well on the assignment. All right, I think that's just about enough about ands, ors, and nots, unless we were going to give more examples in code, and we already did that last time. So, not employee equals 1, and just remember in our language we have to use equal equal. Or, not employee department equals 2. Also remember in our language we don't capitalize not and true. And so that's how we would write this in Python. Also, there's no word then. So that's an example. I just copied it out of the PowerPoint and changed our symbols. Whoops. I pasted it over something else that I shouldn't have. And undo doesn't really work well in Notepad. There we go. So that's closer to Python, right? It still has the output rather than the print or whatever, but you get the idea. Oh, why not fix it all the way? There we go. So if the employee is not in department or not in department 2, no, because if the employee was in department 1 or they were in department 2, this whole thing would evaluate to true. And then the not reverses it. So the meaning of this is, are they not in employee department 1 and they're not employee department 2? Kind of weird that it flips from and or if you put a not in front of it. That's called De Morgan's law. I'm not going to go on into that. I don't want to overload with information that's not in the book. So a range check. We've already mentioned range check should be done with and the book wants you to use greater than or equal to and less than or equal to. To check outside the range, you're supposed to use, I kind of have those reversed up there, but still, not the greater than or equal and the less than or equal to. You're supposed to use their opposites. And I believe I already have mentioned this, that the opposite of that is not that, it's that. Whoops, wrong key. And the opposite of greater than is less than or equal. And why is that true? If x is less than 10, well, if you wanted to flip it and make it check to see the opposite, if you did this, that's not adequate. Why? Because what if x was 10 here? If x was 10, is x less than 10? No, it's not. Is x greater than 10? Well, we wanted it to be the opposite, but it wasn't. It's still going to say false to that. It doesn't handle that edge case correctly. Doesn't handle that boundary case. So to get this to work, you know, this is the opposite of the line above. And hopefully I don't have to show you the other. Take it on faith. If you have to do it for less than, you also have to do it for greater than. And lastly, of course, what is the opposite of equal equal? Not equal, right? we good on this, or do we need to do more? Kind of thumbs up if we're good on it. Alrighty, I saw a lot of thumbs up. If you are confused, read more. That's why we have the book. That's why you paid your $80. And also ask me questions. Making selections with ranges. Sorry about the blurriness of this. I wish they would put slightly higher res versions in their PowerPoints. But this is to calculate ranges of discounts. And they define dollar constants up at the top as declarations. And this isn't in our language, but you know. So if you're doing 10, you get less than 10, then you don't get a discount. If it's between 10 and 24, you do get a 10% discount. If it's between, you know, actually probably 25 and 50, you get the biggest discount. That kind of thing. You get the idea. Let's go and look at the flowchart for that. Is the number of orders less than the minimum range? Then yeah, you don't get it. All you get is discount 1. However, what if it's not less than the minimum range? We got to go check again. Is the order less than or equal to range 2? Yeah, that's cool. Else, no, you got to go over here. Is the order less than range 3? If that's true, you give them discount 3. No, you give them the last discount. Now this one is worth typing into idle in a slightly different format. This is the grade calculation. And we're going to do the grade calculation in 2 different ways. So if you please, launch over idle. And do your file new. Do your save as. Put in your favorite directory. Never save into the Python directories or bad things happen. March 29. By the way, those of y'all who celebrate Easter, happy Easter. Those of y'all who don't, at least enjoy some chocolate if you want. But let's do it. We're going to do a grade calculator. Let's just ask them for their grade. I'm just going to call it G, or GR for shortness. Easy to type. Grade is equal to input. What is your grade? And we have to change it to a float or an int. So GR is equal to float GR because input doesn't return a number, it returns a string. Now for clarity's sake, I usually just hard code 90, 80. Don't type this yet. 80, 70, you know, those kind of grades because it makes it very visible. If I was doing it book style, I would define these as constants. You know, I would call it A, I would call it B, I would call it C, that kind of range. I kind of feel like doing that. I feel like making this as good a program as possible, other than the fact that I abbreviated that too much. So let's define some constants. We're going to do a range, and you're going to be typing that word range a lot, so I would just copy it, highlight it, and do a copy so you can paste it a lot. So the A range is 90 and above. The B range is 80 and above. The C range is 70 and above. The D range, we are deranged today, is 60. Otherwise, F. Now I'm going to code this one exactly like that PowerPoint was, and it's not the way that I think is the most efficient way to code it. So, if your grade is greater than or equal to the A range, colon, print A, exclamation mark. Did we do this last time? Was that a no? No. Good. Else, colon, If grade is greater than or equal to, you see where this is going, B range, colon, print a B. Else, colon, if grade is greater than or equal to C range, print C. And by the way, the next one we type is going to cover the same logic, but it's going to be easier to type. Else, if the grade is greater than or equal to the D range, and I better slow down because I know I type at 90 words a minute, print D. I think I forgot the word if. Go back up to that D range one and put an if you did not, if you made the same mistake I did. And if it's not a D, it's got to be an F. Because in this world, for some reason, we don't assign grades of E. All right, and if we wanted to make it look like pseudocode, we could put end if on each one of these. I don't really care if we do that. Almost feel like deleting it. But that's how the book examples go. Hopefully by now the logic looks pretty clear. You see how it's going to generate A, B, and C, and D, and F. And if the professor ever wanted to change the grade, to curve it so that 80 and above was an A, they would just go and, and fix those constants up at the top. So 80 was an A, 70 was a B, and 60 was a D, that kind of stuff. I think I skipped something here. All right. I do want everybody to get this part typed in, so I do want to check for syntax errors. Anybody getting any errors? Yeah, I typed fast. The indention on this is kind of a bear, right? We're having to match up the indentions exactly to get it to work. So we feel like making this a lot easier. And we could just type in a lot of stuff again. I'm thinking it might save us some time. I hope this isn't a mistake. And just copying everything from the if down to the print F. So just highlight it all, edit copy, and then underneath your last end diff, paste it. Now watch what I do here. Take that else if stuff and make it say elif and then delete it like that. You see what I did? I'm going to do it again on the next one. I have to fix the tabs, but see I have else and if. I want them to be on the same line. So I'm going to delete some of that stuff. I'm going to pull the elif over once it turns orange, except for you. Then we're good to go. I'm going to bring that one over. I'm going to repeat that. Get else all the way over there and make it say elif. And then lastly, that. Way cleaner, right? I don't have to walk around and help you with your indentions on that. It's just so much cleaner. So, the lesson is, if you're doing what's known as an if cascade, you just keep doing if, else, if, else, if, else, if, else, cascade of waterfall, going down the rocks at an angle. If you could replace it with elifs, if, elif, 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 and by the way, other languages like C and Java actually do use the words else, if, but we're using Python, so elif. So if you run it and type in something like 82, it should print out B twice at this point, unless I've got a syntax error. So I'm going to type in an 82, and okay, it printed out B twice. strongly recommend that you jettison this idea and just use that. But the book showed this, and the book showed it as that flowchart, you know, kind of cascaded over here with each decision. And the reason flowcharts do it that way is because flowcharting was invented before languages came up with the idea of elif and else if. You know, flowchartings are probably invented even before programming, you know, just for logical series of steps you have to do. Has everybody got this copied, pasted, and edited? If not, slow me down. I don't hear typing, so I think we're good. Check the PowerPoint. Let's see what's next. Well, so common errors. Avoid dead or unreachable paths. Don't check for values that can never occur. I don't know if I strictly agree with that. What if you want to make sure that they didn't type in, you know, a negative number? What if your grade could not be less than 0? I might throw that in at the very top of my if statements, right? I could go up here and say, if grade less than 0, print invalid, right? So I don't totally agree with that advice. But never ask a question if there's only one possible outcome. Okay? I guess if it's going to do the same thing no matter what their age is, you don't even need to be asking their age. Avoid testing the same range limit multiple times. What does that mean? Now don't type what I'm about to do because I'm going to immediately delete it. But I could do this. Like I said, don't type it. If grade is greater than or equal to a range and, okay, that's enough. Print an A. If grade is greater than or equal to B range and grade is less than an A range, print B, and so on. You see what we're doing? Because we don't have else's, we're having to specify the entire range. And so we're using that variable more than once. And we will keep using it all the way down because we have to check to see if it's between 90 and 99 or 80 and 89. That's way more complicated, in my opinion, than doing it like this. So if you wind up checking the ranges and you're using the same variable more than once, see if you can switch your logic over using elif. What would the error be? Again, I'm going to delete this real fast. What would the error be if I did this, but all of these were just if statements? All right, so I'm going to run it, and maybe I'm going to type in an 80. I want to see it print, you know, a B a third time. Maybe I'll put question marks here to indicate, you know, which part of the code I'm in. So I definitely want to say, when I type in 80, I want to see it say B question mark. All right, what's my grade? Oh man, I made a B, C, and a D. You don't want that. So why is that? Because without the else, these are no longer mutually exclusive. Mutually exclusive meaning that it can only do one or the other. These are all mutually exclusive because they're changed with else's. These are not. If you type in an 80, you're above a B, you're above a C, and you're above a D. So that breaks it. Not any good. All right. Goodbye. Precedence. I think I mentioned this, but just like addition and multiplication have precedence, you always do multiplication, right, when doing math before you do the addition. And an or are the same way. So I'm going to go back to Notepad now. Because like if you had this A plus B times C, which part of the equation would you do first? Yeah, you would do B times C. So you would treat that as A plus parentheses B times C. Well, what did we establish up higher? Which one is multiplication, and or? And is multiplication and or is addition. How do I know it's multiplication? Because 0 times 0 is 0, 0 times 1 is 0, and so on. Whereas addition, 0 plus 1 is 1, 1 plus 0 is 1. All right, so coming back down here, if we had this, A or B and C, ands have higher precedence, just like multiplication. So we would rewrite that as A or, well, I wouldn't say that we'd have to rewrite it, but that makes it clear what's gets done first, conceptually, right? So you would check this first, or the computer checks this first, and then it goes ahead and does the or, just like it calculates that and then it adds that. Same idea. And and or have precedence. And is higher precedence than or. Or that means that or has lower precedence than and. Where do they throw not into the precedence chart, or do they even mention it? Nah. So mixing and or makes logic more complicated. If the logic looks too complicated, go ahead and use parentheses to make it more visible to the human eye. Or you can perhaps nest your if statements just like we were doing. So this looks pretty complicated. What does this mean? If it's a G rating and you're less than 12, what? Then the discount applies. So if it's a G rating and the age is less than 12 or the age is greater than 65, put discount applies. So apparently the only time that the discount doesn't apply is if the rating is not G and the age is somewhere between 12 and 65. So you could write that in several different ways. Here's what they recommend. Following this chart exactly. If the rating is equal to G, then they check 12. And then if that was false, so that's in the else clause, if the age is greater than 65, then you've either one of these cases. I would chain these two with an or, personally. I would make it if rating is equal to G, and then if age is less than 12, less than or equal to 12, or age is greater than or equal to 65, then print discount applies. Now see, the book was arguing that it's better to use nested ifs and elses if the logic is complicated. I think this is a lot more clear than that flowchart right there. Because if you're going to flowchart it, it only has 2 diamonds and it only has 1 print, right? And here we have 3 diamonds and several prints. And conceptually, they do the exact same thing. Kind of one of the reasons why drawing flowcharts out of your logic is not a bad idea. And I know that nobody likes drawing flowcharts, but... So then there's something called the case structure. Our language doesn't support the case structure. So I'm not going to ask any questions about case on our exam. However, when you take the Chapter 4 test, they probably do. And I'm going to show you the way that it works. Switch on my grade. And only type this in if you're typing in notes, because I'm not putting this in a program. If it's A, I'm kind of getting lost here. I'm going to do something a little bit different. Say you ask them for a material. So if the material is equal to ice, then the density is equal to 0.98. You know, I'm just making stuff up. If the material is equal to water, then the density is equal to 1 gram per cubic centimeter. If the material is equal to gold, then the density is 10 grams per cubic centimeter. And by the way, that's how you can tell if something's going to float or not. If the density is less than water, then it's going to float. If the density is greater than water, it's going to go down. And lastly, one more. If the material is equal to aluminum, which is a light metal, so it's not as aluminum. The British spell it aluminium for some reason. Then the density is 5, whatever. It's half as much as gold. And again, I'm making these numbers up. You could rewrite this like this. Switch on the material. And if the case is ice, then the density is equal to 0.98, or just 98. If the case is water, then the density is what? It's 1. If the case is gold, what's the density of gold? Somebody just spit it out. Show me your weight.
Okay.
Yeah. Alrighty. And then if the case is aluminum, then the density is 5. Then we could do an end switch. Again, this language does not support it. C, all the C-based languages, Java, JavaScript, lots of languages support it. What's the advantage? Yeah, I don't know. It guarantees that these are mutually exclusive for the most part. Whereas if you were looking at a whole bunch of if, else, you might not absolutely have a guarantee, because what if one of these was just an if rather than an elif? Then we'd be back in that situation where more than one was possible. One thing to note is that these have to be what are known as discrete values and not ranges. I started off with that grade example because, you know, we've just done grade, but I can't do case greater than 90 and case greater than 80 less than 90 and case greater than 70 less than 80. You know, you can't express ranges. They have to be unique values. And then, you know, as a matter of fact, a lot of languages don't even allow you to use strings there. They will only let you do switches and cases on ints. But that's the idea. Just tuck that away in your brain, because I'm hoping that the vast majority of y'all will take another programming class like Java and C++, which I also teach. So if you like my teaching methods, you can probably get those from me. And just a small plug, if you want to take something over the summer, C++ is being taught over the summer by me. And one more thing I need to mention, which I'll mention later, is that enrollment is open, or it's opening pretty soon. The sooner you enroll in classes, the better, because it's more likely to make, you know, if they see a lot of people enrolling in something, then they may make a second session of it, right? Otherwise, if people wait until the very end to enroll, you know, then they don't know that they need to have a second session of it. You may get blocked out. Or the class may have been dropped entirely because they thought nobody was enrolling in it. So to encourage people to enroll early, a lot of the teachers, including I, offer a bonus for saying you enrolled in something. And, you know, we'll apply that until the end of the semester. Don't tell me yet. It'll like be a question on the exam or something. But, you know, if you tell me that you've enrolled early, I'll give you extra credit on the exam, the final, when we get there. Just tuck that away. Early enrollment is good. So you use a case when there are distinct possible values for a single variable. Here's how they flowcharted it, and that's pretty cool. I hadn't seen that before. I mean, before this textbook. This is one of the things that I like that the textbook did different that I think is totally cool and I'm always going to do in the future. So it's like case year, or switch on year. And then case tuition is that. Case 150, case 100, case 60, and it does something, right? So these are your cases. If the year is 1, that's your tuition. If your year is 2, that. What kind of school gives you tuition that's less and less based on how many years you've gone there? Not this school. Anyways, that's rather optimistic there. I like that flowchart. Am I going to ask for it on the exam? No. If you see it on the test, on the MindTap test, just you know, look it up in the book. Check the flowcharts. All right, summary. Decisions are done using Boolean expressions. So anything inside a diamond is a Boolean expression, meaning it goes to true or false. X greater than 10, Y equal to B, You know, name equals Joe. All of those things to evaluate to true or false. You use relational operators to compare values. What are our relational operators? Those are less than, greater than, less than or equal to, greater than or equal to, equals, and not equals. And the book uses just one sign for that, and I think they use that for that. But since I like teaching to the actual languages we use, go for that. Then there are logical operators. Not as many. There's and, or, and not. Did I talk about when you would want to make an and, which part of the or should be true more often? Like if this is true 90% of the time, you'd want to put it where, and if this is true, okay, good. So in an or, you ask the question that is more likely to be true. In an and, you ask the question that is less likely to be true. I'm just going to copy and paste that into our notes. For a range check, use and. To check outside the boundaries, you use or. And has a higher precedence. And the case structure is a specialized version of all the if-else-ifs. All right. We are done with that chapter. We have so much time left. Let's go take a peek at the next chapter. Any questions over what we've done? And by the way, I don't mind ending a little bit early if somebody says, oh, I'm going to need to talk about, you know, homework number 37. On the other hand, I also don't mind hanging out here for an extra hour, you know, so let's look at the contents. Oh, let's hit the homework first. So we have a homework assignment 7 that's coming up due in a week. Let me see if the document's in it. If not, I need to import it. No document yet. Fix that right away. You gotta be kidding me. Did I open the wrong one? It's not there. Well, phooey. I didn't put it there. I'll go back to that classroom and find it. The way it works is you have 25 questions. Question 1, 2, 3, 4, 5. And it's got some values up in it, like A is equal to 2, B is equal to 10, and C is equal to 100. And then it's got some other values, like D is equal to dog, E is equal to eagle, whatever. So it'll ask for you to solve an expression. Is A less than 2? Is A greater than 2? Is A equal to 2? And they're not quite this easy. And so what you're going to do is you're going to open the Word doc, and there's columns for writing true or false. So just looking at this, as I've written it before, without me coaching you any further, is A less than 2? No, so that's a false. Is A greater than true? It's still false. Is A equal to 2?
True.
That's true, which means that A not equal to true is false. Another choice is invalid. True, false, or invalid. Invalid is when you compare values of different type. Is A equal to D? No way, it's invalid. Is D not equal to E? How about that? Somebody eyeball that.
True.
That is true because they are not equal. And so on. And so you're just going to have 25 of them, and you're going to need to work down through them. And they're drawn from the end of the book, except I revised them considerably. Why? Because I know that the answers to every exercise in a book are available for easy Googling. You don't learn anything by Googling the answers. All right. I will go and get that and upload it later today. Yeah, so annoyed at myself. Yes, sir.
I had a question about the summer school.
Yeah.
How many weeks are those classes?
8 weeks. Right. So, from June 4 to July 31st. That's when the summer semester is. And I'm sure that there are short, accelerated ones like that do it in 4 weeks and 8. I can't imagine doing a class less than 8 weeks, personally. I know that they even have interim classes, where they're shorter still. I've been offered to teach those, and I say, I can't teach something that fast. So if you look in contents, there should be a link for the MindTap exams. Hopefully both 3 and 4 are there. 4 is not there. I'll post it at the end of class. And then it's going to be due a week after 3 was, which is already, I could look at the due dates, but, you still have time to get 3 done, and then, you have a week past that to get 4 done, even though, we're already done with chapter 4. Take a peek at chapter 5. Looping. I'm not going to even hit the PowerPoint for this at first. Instead, we're just going to write some loops. We already have some code open. What is looping? We've already talked about it. It's when you check something, and if it's true, it does some code, then it goes back up and it checks it again. Then it checks it again, and so on. So let's go back to our idle program, and let's write some loops. How about, let's ask them for a number. So x is equal to the integer version of the input of number between 0 and 10. And then you have to have 2 parentheses at the end because we had 2 opening parentheses. That just did it all in one line. I don't care if you do 3 lines of input, right? Print number between 0 and 10, x equals input, and then x is equal to I and tx. They work the same. Okay, now we have a number. Let's start playing with it. X is equal, nope, while x is greater than or equal to 0, let's print something. Hello, comma, that number, just so that we can watch that number. Now I'm going to run this, but I don't necessarily want you to run it unless you just feel like it, because it's got an error in it. It's got a logical error. All right, what's my grade? What's the number between? All righty, why is it doing that? Let's look at our while statement in our body of our code. Why is it an infinite loop? Exactly, we never change the loop control variable. We never change x to anything else. So if it's true, it's always going to be true. So you would do x is equal to x minus 1 or x minus equals 1, something like that. Now let's write another loop. Let's count x all the way up to 100 or something like that. While x is less than or equal to 100, let's print high, comma, x, and let's add 50 to it. X plus equals 50. So to, no, then it's only going to print two numbers. Let's add 10 to it each time. So to print 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. I'm going to test it out. I recommend you do the same. What's my grade? 90. Or not. What's the number between 0 and 10? 5. So it printed 5, 4, 3, 2, 1, 0. And then it started counting our number up, and I made a mistake. I wanted it to start at 0. I should have given it an initial value. But I didn't initialize x, so it was equal to whatever x had been decided up above. I need to correct that. Now that mistake I did not mean to make. So above that second while, let's set it equal to an initial value. And let's set it to 10, so it'll count 10 to 100. Let's not start at 0. What's my grade? 90. Enter a number, 6. Counts from 6 to 0, and then it counts my highs from 10 up to 100. It's behaving as I wished. This loop is working. And is there anything I can help with back there? I hear a lot of talking and I'm getting confused. Are we okay? Alrighty. So what we're going to do next is we're going to rewrite this with what's known as a for loop. A for loop is a specialized kind of while loop. But before I finish working on the for loop, just copy this code right there, copy those 4 lines, paste them, and change that less than or equal to a less than. What is that going to count up to now? Is it still going to count up to 100? Or is it going to stop at 90? Somebody just take a guess, even if you're wrong. Yeah, it's going to stop at 90. Why? Because if x is equal to 100, it's going to do this comparison. Is x less than 100? No, it's not, so it's no longer going to be in the loop anymore. So what do we need to do in order to make this work with a less than rather than a less than or equal to? One simple change I can make. I'll make it that, right? So that x, when it's equal to 100, it's still true. And then once it's greater than 100, it's no longer true. Now, why did I show you that? Because the for loop is going to be structured the exact same way. So for x in range, and this syntax is quite a bit different than it is in C and Java and stuff like that. And I know you don't like hearing that, but it's just true that every language has its own quirks. This one has a lot of quirks, but it's an awesome language. So we're going to start x at 10. We want it to end at 100, so we have to put 101 there. And we want it to be increased by 10 each time. And then it's going to print by, comma, x, just so we have something different on the screen. This time I don't need to update. Update? I sound Canadian. I don't need to update the loop control variable because the for statement does it for me. And so if I read this aloud, and the way other languages might express it is for x equals 10 to 100, really. You can't quite say it like that. Starting at 10, and as long as it's less than 101, keep looping. And every time we loop, add 10 to it. So this is the exact identical code to this. And let's run it and see if our highs and our buys look about the same, because they should. Yep, and my highs went from 10 to 100, and so did my buys. So using that same syntax, here y'all get creative on your own part. Write a while loop that will print from 5 to 10. And then write a for loop that will print from 20 to 30 by 2s. Right, so you're going to have to be adding 2 each time. And the syntax for both of those can be seen just right here. This stuff right here is your definite helper. Tell me I started the record again. Yep, okay.
In the last, in the 4, the X-ray is the space between the 101 and the 10 necessary for it to count like that?
Right, this is the value that it's initialized to. This is the comparison. This is the update. And this just pushes it all into one line. That's your initialization. That's your comparison, as long as it's less than that. And that's your update. That makes sense, or I didn't? Okay, cool. And I'm also going to tack on some more that I want you to do as homework. It's going to be pretty easy homework, though. I've already given you one homework assignment and a quiz, so I'm not going to make this one too much. Write a while loop. This is homework. That counts from 100 to 90. Write a for loop. That counts from 100 to 1000 by 10s, by 100s. That's about enough. You can do those in class, actually, huh? Those are so simple. I should have made it longer, but I didn't. Hide those. How about that? Alrighty.
Can you scroll down a little bit to the homework assignment?
Nope. You're going to open the homework assignment when I post it. It's possible I may add a few more things to it, because that's pretty lame. Turn in homework that you could write in 20 seconds. All right. All right, this is Dropbox. Jay, just refresh it. You'll see Jay. Feel free to upload once you get it, and you're done for the day. Let me wander around and see how you can find this. And I'm not trying to be nasty, but I'm really going to add some more things to it. So. That looks like a colon. I'm surprised I didn't make that mistake. Let's go look at the file and see what it is. Oh, you see why it's because this for loop is nested inside this while. So just push that back and store it back. So I just walked that. You got everything going? All right. So bounce down, shallow work. Up from 5 to 10. Good job. Refresh it should be J. Oh, I just don't have. I don't have brakes on. Yeah, but that's the one that the audios is gone, so just go to the notes, find the code, and look at it. You're so you're right there. It's right here. Oh, you're right. It's not locked. Okay. I mean, not. It is locked.
one that is locked.
Okay. My mistake. All right. See y'all next week. All right, guys, I did not intend homework 5 to lock after its due date. That's never my intention, so I just need to correct that. Or the sphere program, which is not 5, my mistake. Yes, sir. Yes, ma'am. Sorry.
You said there was a quiz, is that the questions?
Right, right, right. something being vexing.
Yeah, I lost my, sorry about that, I lost my,
Oh, you lost your last file.
yeah.
Let's see, file, recent files.
Oh,
Okay, good, yeah.
thank you, sir. Yeah, give it a minute. Yes, I deleted the homework there.
Oh, you too?
Nose. Fuck you. The fuck? Fuck you. Fuck you. Fuck you.